Hello, and welcome to our AP exam review. In this video, we're going to talk about topic 3.10, solubility, and how different substances will dissolve, different solutes will dissolve in different solvents. The key to thinking about solubility is like dissolves like. And so that's a phrase that I'm going to bring up a little bit in this video, but like dissolves like simply means that substances that are like each other in polarity will dissolve in one another. So polar substances tend to dissolve in polar substances, and nonpolar substances tend to dissolve in nonpolar substances. So when you're thinking about whether something will be soluble, the important thing to think about is looking at the solute and deciding if the solute is polar or nonpolar, and then looking at the solvent and deciding if the solvent is polar or nonpolar. And to do that, you have to look at the molecular structure, if it's a molecular compound, or you need to look at whether it's an ionic compound. So our first decision you have to decide is the solute polar or nonpolar, and is the solvent polar or nonpolar? So the first thing I want to talk about is what are called ion dipole attractions. And in ion dipole attractions, you have an ionic compound that dissolves in a polar molecule, a polar substance, because polar substances have dipoles. If you recall, water is a good example of this. Water has a dipole. One side of the water molecule is more negative than the other side of the water molecule. So one side of the molecule has a partial negative charge, and one side of the particle has a partial positive charge. That means that if you have ions can be attracted to the water molecule because opposite charges attract. So the negative side of a water molecule will be attracted to the positive ion, and the negative ion will be attracted to the positive side of a water molecule. And so ionic substances are soluble in polar substances because the positive and negative poles of the polar substance will attract the ions to each other. So that's the first way that something can be soluble. Is it ionic, and is it dissolving in a polar substance? If you had a nonpolar substance, and a good example of a nonpolar substance would be methane, which is CH4. Every side of the methane molecule is identical to every other side of the methane molecule, and so this is nonpolar. One side of the molecule is no more negative than another side of the molecule. So there's nothing on this molecule to attract the ions in an ionic compound. So if you had a nonpolar solvent, it would not attract the ions of a ionic compound. So like dissolves like here, ion dipole, ions are charged, dipoles have partial charges, and so they attract one another. Okay? So the solute would be polar, and the solvent would be polar, specifically ionic and molecular. The next type we're going to talk about is hydrogen bonding. In hydrogen bonding, you have a specific type of polar substance and polar substance for the solute and solvent. We have substances that contain an OH, an NH, or an FH. These are extremely polar bonds. And so if a molecule has one of these extremely polar bonds, they can strongly attract other substances with that extremely polar bond. For instance, water, which has OHs, has very polar bonds, which creates a very polar molecule. Ammonia is the same way. Ammonia has NHs, and those NHs are very, very polar, which creates, again, a very polar molecule. And so the negative side of the water molecule can strongly attract the positive side of the ammonia molecule. And those create hydrogen bonds. So if two substances are capable of creating hydrogen bonds, then they are going to dissolve in one another very strongly. So both substances have to be polar, but not just polar. They have to have an NH, an FH, or an OH in both substances in order for that attraction to occur. And that'll occur through hydrogen bonding, which will allow the two substances to dissolve. The next example of substances dissolving each other are dipole-dipole forces. And in this is simply a polar substance dissolving a polar substance. The opposite poles of two polar substances will attract each other and allow them to dissolve into one another. And so that's going to be easy for those two substances to dissolve in each other. Another type of dissolving that can occur is a dipole, which are in substances that contain polar molecules attracting nonpolar molecules. Now, if you'll notice, this does not follow our like dissolves like. If something's polar and something's nonpolar, then that's not a recipe for attraction. However, they can attract each other through what's called an induced dipole. If you have a substance that is nonpolar but is fairly polarizable, and let me get rid of all of this. If you have a substance that's fairly polarizable, and polarizable means that it has lots of electrons in the structure, and that those electrons are capable of moving and shifting to one side or the other. So if we put iodine, which is nonpolar, into water, which is quite polar, the polar water molecule will induce or create a pole in the iodine molecule. So the negative side of water is going to repel the electrons in the iodine just a little and create what's called an induced dipole. That induced dipole is now going to be able to be attracted to the water molecules. And through that attraction, the iodine will stay slightly polarized. So iodine doesn't dissolve greatly in water, but iodine will dissolve slightly in water due to this induced dipole that's created in it. Now, small molecules, such as methane, is not very polarizable. There's not very many electrons in the molecule, and so they can't shift very easily to create an induced dipole. So methane won't dissolve in water hardly at all because it is very hard to induce a dipole in that methane molecule. So dipole-induced dipole, this is a nonpolar solute dissolving in a polar solvent, but this is not going to happen very well, and it's due to that induced dipole in the solute. The last thing we can have is what's called dispersion forces. And dispersion forces occur in between nonpolar substances. And obviously, these are going to be very weak because nonpolar substances do not have poles to attract each other. So if I had methane and iodine, both of which are nonpolar, you're not going to have a strong attraction between those molecules because there's not a positive and negative side between or inside either of those molecules. So one does not have a partial positive and partial negative to attract a partial positive and partial negative in the other. And so they can attract each other very, very, very weakly due to momentary dipoles, which means the electrons randomly are on one side or the other and create very, very, very small dipoles. And then they might be able to attract each other weakly, but they're not going to dissolve very well at all because there's not a positive and negative side to attract each other. So solubility depends on whether you have positives and negatives in the two substances, and those can attract each other. You need to look at each substance and decide how positive and how negative it is, and that's going to affect how well they'll dissolve in one another. That's just a brief rundown on solubility. Good luck with your studies. Bye-bye.